Hello everybody, welcome to the Arcadia workshop. All presentations in this session are linked to the Arcadia project. Arcadia is the European Commission funded H2020 project. And this is the third workshop for us. This is the third final workshop. The project is actually entering the final stage, so the project should be finished by the end of the year. And this is our final workshop. First, I will give a short presentation, introduction to what Arcadia is about. Doesn't switch the slide. Okay. Arcadia, as I mentioned, is a Horizon 2020 project, and it started on the 1st of January 2015, and we are running till the end of December 2017. We have 10 partners involved. Myself, I'm representing Insight Centre for Data Analytics at National University of Ireland, Galway in Ireland. We are the coordinator of the project. Our partners include Sinte from Norway, TU Berlin from Germany, we have CNIT from Italy, our friends from Slovenia, University of Slovenia, we have Ubitech from Greece, Winx also from Greece, Maggioli from Italy, and Adites from Cyprus. So this is the consortium. The total funding of the project is about 3.5 million euro. The full name of the project is a novel reconfigurable by design highly distributed applications development paradigm over programmable infrastructure. It's a very long title, but it's very expressive and really explains what the project is all about. So it's all about reconfigurable by design applications that will be highly adaptable. And we talk about distributed applications here, and this is the main aim of the project. Arcadia in a nutshell. So we have four basic components to Arcadia. We developed a distributed apps development environment. That's one part. We have a policy aware orchestration, multi-data center execution middleware, and component and application discovery component. So these are like four pillars of the project. And now we will go through several presentations where we try to explain more in detail how Arcadia or Arcadia framework works. I will start by giving a bit more general overview, and then you will see how our cases work. So we have three cases that are based on Arcadia framework, that leverage Arcadia framework. So to start with the first paper, this is the title, Addressing the Threats to Critical Distributed Applications Using the Arcadia Software Development Paradigm. So here we are focusing on one of the aspects of Arcadia framework, which is ability to provide resilience by design, resilience by default. And I will shortly explain how is that implemented. First, the motivation behind our work here. As we can see, the systems, all sorts of systems become more complex and heterogeneous. When we talk about cloud computing and cloud systems, the infrastructures become very complex, and that comes at a price. One of the biggest challenges is to ensure that the system or the infrastructure is resilient. And when we talk about distributed applications in particular, resilience have a very deep meaning here, because when you have distributed application, part of the application can be hosted in many different places, and we want to ensure that it all acts together, and in case of any failure, whether it's a component failure or node failure, that can be handled and the application will continue to run. So this is the basic motivation behind the work here. So I will shortly describe resilience for those who are not very familiar with the concept. So I use two definitions here. There is many actually, but I believe those are quite expressive. So the resilience is the relative adaptiveness of the system to handle disruptions and environment variations going beyond explicitly implemented exception handling. Yes, so something happens that was not anticipated by the designers, and yet the applications should be able to deal with that exception, without interruption or with minimal interruption. And so then we have another definition which in my opinion is kind of complementary. So any resilient system should be designed to survive and recover the event of hardware or software failure of individual system components. So here we have a bit more granular definition. So we talk about hardware and software failure. So in case of any event, both of these aspects, hardware and software, both of these components should not lead to the total failure. Yeah? And so in principle, I think resilience can be explained as ability to be adaptive. And that's why I have this interesting picture here of our evolution, which a bit of a twist at the end. I think it's regarding the climate change. Basically, we as beings, but also as working systems, we adapt. Yeah. So we are actually very heterogeneous systems with different organelles, and it all works together. But we need to adapt to a fast-changing environment, and so we can say we as a system, as individuals, and also as a social system, we are kind of resilient. And this is what we also try to mimic at the more computational level here. And when we talk about resistance, we talk about context awareness. So when we have distributed applications, and there is a requirement for configuration and reconfiguration because of some environmental variable change. Often this is performed manually these days, or there's some weak automation, semi-automation. So context awareness emerged as a kind of a new paradigm here when applications are aware of their surviving and can react, can adapt. So therefore we have a resilient application. Yeah? So we have context-aware applications which now become resilient. And to be more specific, how it is phrased in Arcadia framework, so we have HDAs, which is highly distributed applications, and this is the term we use within our project and in all our publications. So in Arcadia, we consider that they are reconfigurable by design and scalable. So this is kind of a redefinition of context-aware application. Yeah, it's richer here. So so basically, we extend this concept of context awareness, and so we are not only adapting but also offer specific network reconfiguration. Yeah? So if you have a network of components, we can also shuffle specific elements there. So there's an extra add-on here. So to put it a bit into image, basically Arcadia framework enables to scale out or scale in infrastructure, and that might be important from the perspective of a high demand for computational power or savings where the computational power is not required. So we can scale out our application in the high demand period, and then when there is not much demand, we can scale in. Therefore, we can save resources, for instance, right? And then we also have another, I would say, secondary aspect to Arcadia framework, where we add the rerouting of the components. And this is more related to quality of service. Basically, we are now able to move specific components between the nodes. So in case of underperforming component, we can switch to another node, or if there is a failure, complete failure, we can switch. So there is a extra granularity added here. So in the heart of the Arcadia framework, we have what we call the Arcadia Smart Controller, and this is a component that covers the deployment of the applications over the infrastructure, and it's sort of a manager that manages all the applications and is responsible for reconfiguration on demand. Yeah. And this is accordingly to defined specific policies. And here I have an example. This is actually a real example of the line from the code where we see three different policies. And so, for instance, we have some constraint here that queries per second higher than 2,000, then scale vertically, yeah. And then if more activity there, then scale horizontally, and so on and so forth. So, thanks to these policies, we can adapt accordingly. So to facilitate the deployment and further the application monitoring, we use the annotation mechanism, which is an important part of Arcadia framework. So you can see, I hope it's visible there, but there are annotations in the code where you can see, for instance, the Arcadia metric, line 13 and 14. So basically, inline in the code, the developer can already specify annotations that are later picked up by the service orchestrator responsible for application deployment and running. So it's actually already in the code, and so it's kind of an automation here, that there is no need for manual intervention. Yeah. To sum up here, basically Arcadia implements 3 phases of the service lifecycle. We tackle application deployment, deployment script preparation, and policy specification. Just to be more concrete, how the system would work. So in case of a component failure from the resilience perspective, you can see that there is a request response for component 1, 2, and 3, and the second one failed, so we have a mirrored component in another node. Yeah? So this way we can avoid, so for instance, if for any reason or this component maybe is underperforming, we can switch to a component in another node to compensate the loss there. So this is at the component level, but we can also have at the node failure level. So for instance, this is in case of emergency natural disaster, one node is completely offline, the system can switch to the safe node, and we continue to operate at less capacity maybe, but operational. Yeah. So this is the I would say basic contribution, I would say by default or by design in Arcadia towards resilience, and this is how it's followed in some of our cases. In our project, we have 3 basic cases. One is actually with our partners here in Slovenia, with the 6 on dashboard, and that project largely deals with resilience and basically survivability of the system. So I would say that's the case which draws the most from the resilience built-in aspects of the framework. But also we have the case of quality of service and energy efficiency, which benefits from the capabilities of switching the components, and in case of underperformance, or so switching more nodes, or switching off the nodes in case, for instance, we want to save the energy. So there is a secondary benefit here in form of optimization. And finally, we have a security and privacy case, which also builds upon the framework. And the following presentations, which happen shortly, will go more into details on all of these cases. So that was a short introduction. I'm just in time, I think. So I will pass it on to my colleagues now, and I'm waiting for questions. Thank you very much.
Thank you.